welcome everybody to today's webinar. We'll be talking about an introduction to FastFinder, which we like to call a better way to analyze PCR results. There's two of us in here. First one is me. I'm Thomas. I do marketing at Genentech. And there's also John Towns, who's our lead field application specialist here. He has a background in NGS and has worked in multiple life science companies, and now currently helps Genentech customers roll out our solution for PCR analyses. Today's topics include a little bit on how it works, FastFinder. We'll go shortly over machine learning for automated analyses, assay plugins for assay-specific settings. We'll talk about the benefits of a cloud-based software and the benefits of a device-agnostic software, as we like to call it. Then John will continue, and he'll go over the introduction to FastFinder, where he'll talk about quantitative PCR analyses, multiplex PCR analyses. He'll also demonstrate the integrated quality control follow-up, and of course, archiving, exporting, and reporting of your PCR data. So if you have any questions, there's a dedicated questions tool. We'll do our best to answer all the questions during the webinar. Should they not receive an answer, you will definitely get an email afterwards, so feel free to ask questions. Should you drop out due to another meeting or due to another responsibility somewhere else, a recording will be made available afterwards for you, and you can watch it as much as you'd like and when you'd like. So, starting with the intro to FastFinder, how it works. I will go over this briefly. So first up is machine learning, which is one of the core technologies used in FastFinder. And to explain this a little bit more, and we like to use the metaphor of a simple car sensor. And we like to think that computers used to do easy tasks with ease. For instance, you can see this car here, which has a simple parking sensor, and if the signal is 1, it will alert the user with a beep. And we like to believe that some of the industrial PCR software out there does a very comparable analysis of a situation. So if a fluorescence passes a certain threshold, then this curve is a positive, which of course is not the truth if we are seeing some artifacts or if there is a very low or late amplification. So moving on with that metaphor, we like to see our software a little bit as the intelligent cars that we see these days that use techniques used in artificial intelligence. So in the metaphor of the car, there are now cars that can scan multiple objects, and they can detect even very difficult traffic situations intelligently, which are usually tasks that you would say a computer is not capable of. But we are seeing Teslas on the road now with autopilot functions. And FastFinder is very comparable in that sense. So in a way, it calculates a lot more, and it looks at an entire situation that occurs around the PCR curve. So we know that negative curves have a lot of noise. So we look at that feature, is there a lot of noise? But we also look at different slopes at different angles, and there's a lot of literature available where different CQ detection methods are proposed, so we also incorporate those into our results so that we have a more complete picture of a situation. We developed this technology together with the KU Leuven, which has one of the world's most valued data science departments, and we also did an IWT, which is an Belgium grant for innovation for this project. So why do we use it? Of course, as we explained, some of the current practices aren't ideal. They rely on the industrial algorithms and user-defined settings. We usually see that because users know that the software does not score perfectly, they don't rely on it, and it's actually not fit to automate it. And there has been a lot of academic criticism. Some of them are Shane and Gaschini, where they also propose new methods to automate this PCR analyses. So that's the part for the machine learning. Then we've invented something quite revolutionary, which is assay plugins. Assay plugins are the backbone of customization in FastFinder. So let's say we have a specific assay. If we look at that assay in a way, we could analyze it and say that it has different contents. For instance, there's an analysis type. Let's say this assay is a quantitative analysis. There's targets and channels. It's targeting a virus over the ROX channel and something else over the FAM channel, and an internal control over the CY5 channel. It has a decision tree, maybe for a multiplex test. A certain result in the ROX channel indicates that another result indicates something else. So we look at what is the logic behind the assay. There are some device-specific settings. Some devices require a color compensation, and in our case, or in the data's case, there is a way to look at the data. So we know that some assays incur some types of artifacts that need to be ignored, or sometimes there is some specific amplification. So all these things is what we analyze here at eGentech, and then we actually turn that into one assay plugin, which we like to display metaphorically as a tape or a cassette, if you will. And these tapes or these cassettes can be added to our platform, which is FastFinder, without having to change the entire platform. So you could add a melting analysis, a high-resolution melting curve analysis assay for a respiratory panel. You could have a simple amplification analysis for a rhinovirus. You could have an amplification analysis for a flu, and a quantitative analysis for an adeno. And you could all run these alongside each other without having to revalidate the entire tape layer every time. So what this means is that when there's an outbreak, for instance, what we saw for the Zika virus, we can relatively quickly come up with a new tape or a new cassette, if you will, and actually validate that as a separate entity instead of revalidating the entire analysis software. And of course, even the most complex multi-well multiplex assay is analyzed with a single click, because we turn these decision trees into code. As you can see here, we can incorporate negative controls, positive controls. We can link certain results to each other. If result X or Y is A or B, then result Z and A means C and D. And the only thing the user sees is this spinning wheel that says analyzing and has a countdown, and at the end he gets an overview of his results. So that's actually what we like to call a very easy way to go over it, and in 3 clicks you'll actually have even the most complex assay analyzed with FastFinder. So we also host our solution in the cloud. And we'd like to start off by doing a little bit of disambiguation here, because there's a lot of misconceptions about the cloud, and even sometimes people think that it's impossible to host solutions on the cloud in a healthcare environment. And cloud software was familiarized by large companies in public settings, for instance, Google, Amazon, and others. And cloud computing is actually no more than the delivery of computing services from a centralized location. So this can include hardware, for instance, servers, or software, for instance, certain licenses, networking, databases, and much more. And we, eGentech, we're what they call a software as a service company. What means actually that we're not focusing on all these different difficult aspects of software, which are usually setting up servers, maintaining these servers, setting up databases, doing all that pretty irrelevant stuff for you as an end user. Actually, what we like to do is we focus on our core product, and we use a cloud platform provided by Microsoft, which is called Azure. And this is actually hosted in well-defined physical data centers, which have very state-of-the-art security measurements. And what's important to note is that every customer has its own physical database, and gets installed in a data center in the same region as a physical laboratory. We know, for instance, in German and UK settings, there are often local regulations to comply to, and Microsoft actually has put a lot of work into complying with these regulations and setting up local data centers where the data can be put. And lastly, to use our application, you don't need to be able to go on Facebook or any other internet application. And there's only one gate to your database, which goes over the internet, but it's not the internet as you know it. If you can't surf the web right now in your laboratory, you won't be when FastFinder is installed. So there's no breaches in data integrity within your laboratory. So just to make everything around the cloud a little bit more clear. And of course, it's much more secure. Stop using USB sticks with patient data on them, which is always a problem and always risky. A couple of months ago at the VUMC in Amsterdam, about 2,000 patient records were stolen from a car. So if you don't have them on the USB, you can't lose them. No more emailing, faxing, or printing the data around. I think some of us definitely know that. Can you have a quick look at these curves emails, or even printing them out and having a proof of an audit trail with a physical stamp? Our solution is actually fully paperless, so you don't need to fax or print anything anymore, and definitely no more mailing around. Just to give that all in an overview, you have a very small application which we call a client on your computer. That client sends data to a facade, as we like to call it, and that facade then distributes that data to, for instance, what we call the platform API, which is where the analyses occur, or the admin API, which is where we count the number of analyses you perform, but also manage the users in your laboratory. This all is done over SSL encrypted connections, which is the industry standard for data security over the internet. So there's no other ways to any other application. It's only this facade, and it's over an encrypted connection. The data is fully de-identified, and only a sample barcode goes up. No more patient names or records. It's fluorescence data, like you can see below. Someone who does not know PCR very thoroughly cannot do anything with it. So what we like to do is we call it secure by design. There's no way anybody could do anything with this data because they do not have the link between the sample barcode and the patient name. So actually using our solution to analyze your PCR results makes it even more secure than hosting it on-premise. It's cost efficient. You don't need hardware installations in your hospital. You don't need to wait for your internal IT department to set up things. Once they have the gate open, you have access to the highest end Microsoft hardware. There's all the calculation power you need in the software, even if you're running hundreds of thousands of data points or PCR curves per year. We can scale with you as your laboratory grows, and as we say, at any given time, you have enough power to use our application. The last part that I'd like to cover is what we call device agnostic, or the device agnostic nature of the software. We can integrate with any PCR platform we prefer. We have some integrations built already. We can do the Rotorgene, the Bio-Rad CFX, the Light Cycler, the Agilent MX3005P, the Smart Cycler, Light Cycler 480, or Roche. We can do the ABI 7500, the VIA 7, and we can do the Abbott M2000, and we have more PCR platforms in the pipeline. So we're constantly building new integrations with more PCR platforms to support all of our users. You don't need any extra spreadsheets for this. You don't need to handle the data beforehand in other software. You don't need separate list integrations with separate of your PCR systems. Instead, you have one software that aggregates all the cyclers you have in your laboratory. We have a direct LIMS integration. So what we like to call it is one comprehensive and intelligent and user-friendly software that works with every assay and on the device you prefer. Just to round that up right there. I think my part's done for now. I think we've all been eagerly waiting for John to go ahead and show you the ins and the outs of FastFinder. So without further ado, I'll just give the screen to John.
Okay, thank you, Thomas. Also to introduce myself, my name's John Towns. I'm the Field Application Specialist for Gentek, and I'll just be taking over some of the what Thomas was actually talking about as how it looks and works in our software. So I'm going to be talking mostly to a kind of a clinical user, but of course it's important to remember that all of the functionality I'm discussing here is important in any laboratory, really, following good laboratory practice and the standard sort of quality control procedures, especially anybody accredited to 15189. So I'm going to simply log into the software. And on that note, really, everything I'm doing after I logged in is audit trailed with my name, when it happened, so the user and the timestamp. And this also means that you don't have to do constant, typing in of signatures, for instance. So just to explain the environments of our software, it's sort of designed to feel like a browser. It's not a browser, obviously it's a local client, but it's designed to sort of feel, if you've done any kind of online shopping or you've navigated a website, this should feel pretty intuitive, and you can simply navigate between different screens via the buttons above. So what I'm going to do is walk you through a standard analysis through here, and of course Thomas talked about a quantitative analysis, of which I can show you two varieties. So I'm just going to select the data file that I want to analyze. You can see that sometimes where did I get that from? Well, you can point a default directory towards a folder which outputs the data file from your cycler into that location, and then you simply just need to select the experiment that you want to analyze. And in some workflows, or even in the majority, the software is designed so this is often the only decision making that the end user has to do. And simply click Next. So what this is actually doing is, as Thomas was talking about, we support a variety of different file types. What that is actually doing in the software is simply reading the file and getting all of the information out of the file as to which well positions are qualitative standards, which are samples, which are negative controls and positive controls, etc. I'm going to assume that this is a kind of a default workflow. I'm not adding anything. I'm not repositioning any samples in the plate. I'm simply just going to check that I have the right test set up on my plates and proceed. It's important to say here that I have gone straight from the data file, of course, and of course I can integrate more than one test on the same plate, given the cycler conditions actually allow you to do that. I'm just going to click Next. So this is the second click, and I've got into a configuration screen. Essentially, this just displays the device-specific settings here, the color compensation file, and the assay-specific settings around lot numbers. You can see that it's a qualitative analysis, and the concentrations for this are defined at the standard curve of the quantitative standards in the plate. So again, given a default workflow, I'm simply going to check the lot is okay and proceed to press Analyze. So what the software is actually doing is on the cloud is using the artificially intelligent algorithm. So this is the algorithm that's been trained on the assay-specific data to analyze every single curve of all the standards, all the controls, and all the samples in every well. And of course, that last little blip there you could see was the implementation of the decision trees. So this is, as someone's mentioned, the conditional stuff about your experiment that is, or your test that is expressed in your standard operating procedure, or simply trained per technician. What happens if positive control passes or fails, and you get a positive detection of a sample, etc. So it's important to say here that you can see that I've got all my my target information, which targets were detected. Scroll down a bit. Which target detected, any concentration information, etc. And for a normal analysis, I simply need to proceed to authorize these results. This is the nature of the authorizer, the automation aspect of FastFinder is that you can essentially all samples are judged essentially as a probabilistic output from the algorithm. So if they fall within a certain degree of confidence, you can simply pass the results without review. And I'll show you what happens when we get a result which for which the algorithm is not confident later. I can still access all of my results simply by clicking into the sample name and select the particular targets that I want to analyze in the normal manner. I can also, for instance, select which kind of graphing I want to view as well. So I'm going to open another tab here, another couple, and so this is this tabular field is supposed to again feel a bit like a browser. It kind of implements the fact that you can run multiple analyses concurrently. So I'm just going to select another file and begin a new analysis by clicking next. We're reading our file again, and the important thing to say about this test here is that you can see it's also a quantitative assay without having the standards in the plate. So I can also, for instance, perhaps edit this sample around and add in new samples as I wish, or revert to the default. So in my next screen, I can simply choose a pre-saved standard curve, and of course, for all authorized results, I can save any standard curves into the assay plugin and bring them in at a later time. So while that's analyzing, I'm going to simply select another file to analyze, just to show you what happens with a kind of contested result, and to show you another plate layout here from this experiment, which is that you've got, for instance, mix 1 and mix 2 here, and at this point it's interesting to distinguish what we mean by multiplex, multi-well. A multiplex assay might, for instance, be a single sample in a single well that has multiple probes designed against different targets. A multi-well experiment might be that a sample is spread across 2 or more wells. And in terms of the decision tree, this is again all automated in the assay. So if there is something contingent upon 2 different wells for the same sample, all of that decision making is again automated within the decision tree, leading to a combined result. So you can see here I've got multiple lots. Perhaps I'll select a different lot. Maybe I'm using 2 lots concurrently. And I'm being shown here that I have a more recent lot available, which I can simply overrule. if I can revert to our second experiment here, again, this is simply a repeat of the example that we have 3 targets detected. I've used the preloaded quantitative quant curve to actually detect the concentrations for this target. And again, I can simply look at this and pass out, authorize this without review if I wish. For some results, you can see here I've got this red 2 above the Resolve tab. So as I was talking before about that some results are, have contentious outcomes, the algorithm has delivered an interpretation that's not in the degree of confidence that we would like in the outcome. What we can see here is that we've got 2 results that we've output to the user to actually overrule. So the user is simply being asked to look at these curves and to provide a judgment on whether they are positive or negative. The algorithm has said that it's positive and we can agree with that result, or it is saying we can overrule it and say that it is negative. So whatever the particular outcome is, perhaps if I agree with it, I can simply press tick and resolve. For this sample, perhaps I want to overrule it, so I can simply select that I think that it is negative, provide a interpretation, and again resolve the sample. And as you can see, in our audit trail column, you can have access to all of the actions that are performed in this experiment. And this is again, I don't need to type in any passwords, anything like this. It's all completely automated within the software. And I'm going to authorize the analysis. So that's a simple workflow that consists of selecting the experimental file, passing the data, and automatically setting up the plates, and then simply running it through the automated analysis workflow in 3 simple steps. And you can see that I've gone from a data file to an interpreted result within 4 clicks. So what about the next steps? So in terms of what Thomas was talking about earlier with LIMS integration, I can select a file type output, for instance an ASTM file that outputs to a default location. And of course, as Thomas was talking about, in terms of our paperless workflow, I can simply select a PDF that contains a variety of information that I need going forward, and click Export. So this is designed to have as many features as possible, really to put the control in the hands of our users, so that we're not delivering a product that is not that dictates your workflow, but fits around the existing workflow. So for instance, for this result, I've selected the ASTM integration file. I'm going to use the default directory that hasn't been set up. And I can simply send to LIMS there. Depending on which kind of LIMS service you have, of course, this might be then automated to be incorporated into the LIMS system. I'm going to skip back and talk about some other features of the software. So for your, for instance, your standard curves and your positive reference curves, everything is saved in here in your assay plugin, as well as the name tags that tell the software exactly what is a positive and a negative control, your targets, the product specification sheet, etc. The important thing about this is that this is also where the lot management actually happens. So I can simply click a plus sign here and add in my new lot number as I've opened it. And select an expiration date. And now what I have in the second screen is an option to specify some tracking options for the positive control. So I'm going to specify what I want to track as a positive control. It can be any of the targets in this particular assay, and the number of analyses for which, after there is a period of floating statistics applied, we can fix a mean and then simply compare the performance of the positive control in CQ values in a Levy-Jennings charts as a distribution of standard deviation. So I'm going to click that, save. What this ends up looking like is, of course, it means that simply by specifying this criteria each time you put in a lot, it means that you can have fully automated QC tracking. So as you can see here, for this particular lot, you've got a range of distribution within one standard deviation in this green bar here, and you've actually got 2 consecutive lots that have more than 2 standard deviations from the mean observed in the CQ value of the positive control. And this has actually triggered a violation of the Westgard rules. This will output to the user in the overview tab during the actual analysis workflow, so that they have to provide an interpretation on this batch. What we normally see is, of course, people adding things into spreadsheets, putting lot numbers into spreadsheets, and then if there's anything going on downstream with that, in terms of the quality control analysis, it's often a case of recovering this from the spreadsheets in either a completely manual or a semi-automated way. This can take time, and of course it means that there's a time lag from actually when you're doing this analysis to when you are actually getting the quality control data. What we do is, of course, build this into the software so that it is output to the user in real time, so that there's no delay between an outlying batch being discovered and being able to react to this in a quality controlled manner. And as you can see, I can apply actions here in an audit trailed way. And of course, I can have an output and control of which Westgard rules I'm applying in my laboratory. So what do I do with that information in terms of reactive troubleshooting? So as we said, we've got this very nice tool, which is the real-time quality control tool. But what we've actually built into FastFinder is an archive of every analysis that you performed. So what you can actually do is, of course, specify some criteria where you can dynamically filter this archive and say, for instance, if you think that you've got a faulty instrument, you can, for instance, select the device name and apply multiple filters. So I can say that I want to see everything that's run on this device within the past week. And in that case, you can simply, within a few clicks, get access to all of this data. If you need to access the reports for any of these, you can simply click into any of these projects as a hyperlink and reprint the reports or get access again to the data. What we see important for some users is, of course, for instance, maybe I want to see for a particular targets, I want to see all of the positive results in a given time period. And again, this is simply a case of applying multiple filters and then searching the archive so that I can access all of these results and simply count them in a dynamic way. And coming to the end of our demonstration, I'd again just like to emphasize that all of this information is essentially managed by the end user. So again, we're not handing down a given workflow, because the actual software is designed to be controlled by you and to fit flexibly into your laboratory workflow. Okay. Back to you, Thomas.
Right. So that concludes the demonstration part of our software. I guess we have some time left for Q&A. I'm going to open the questions right here. And I can't immediately see. So again, any questions are free to come in.
So we have a bit of a webinar feedback telling us that that you guys are muted. Yes, you all should be muted. Any questions that you have, please feel free to just type them into the questions pane, and Thomas and I can answer. But thank you for your feedback.
I guess we can round it up then. Thanks everybody for attending. I'd like to finish off by wishing you all warm and happy holidays, and we will probably see you in the next webinar, but that will be for the first quarter of 2018. So thanks everybody, and we will see you in the next one. Goodbye.